Hello everyone, I'm Marcus, the Open Science Officer at ITC, which is the Faculty for Geoinformation Science and Earth Observation at the University of Twente. In this presentation, I would like to talk a bit about open licenses. Licensing is a complex issue, and I cannot give legal advice, since I'm not a lawyer. So I cannot tell you that you should use this or that license. But what I can do is to give you a brief overview and some initial insights into open licenses. I hope that by the end of this video, you are able to understand why licensing is important, describe which licenses exist, consider different aspects when choosing a license, and choose the right license for your paper, data, and software or source code. Let's start with the basics. If you create some creative content, you have the copyright on that content. But if you put this creative content on the web, you make it accessible to others. Copyright means that only you, as the creator of the work, have the exclusive right to reproduce, publish, modify, and distribute the work. Others are not allowed to do these things unless they ask you for permission. By assigning a license to the scientific article, you still retain the copyright, but grant others the right to do certain things with your work under certain conditions. A license defines if and how others can use, modify, and share creative work. Licenses can be applied to any materials that can fall under copyright. For example, books, datasets, articles, photographs, or videos. Licenses work alongside traditional copyright law, which means that violation can result in accusation. On the one hand, this means that creators can share work while maintaining a level of control over how it is used. On the other hand, this also means that if you don't put a license to your materials, nobody knows if reusing your materials is allowed and if there are any restrictions. So you will lose control over your materials. So licenses are a means to provide others with clear instructions on what is permitted and prohibited. In this context, an open license is usually permissive when it comes to using, modifying, and sharing materials. But also open licenses can have some terms and conditions that clarify what exactly others can do and what is not allowed. As I mentioned before, a scientific article is an original and creative work. This is not always the case with research data, which is seen as a description of facts, and copyright cannot be applied to facts. The following example illustrates this issue. E equals mc squared is a fact. I can just use it in my presentation without asking for permission. This would not be the case if I would reuse the text Einstein has written about this equation. However, if you express or represent research data in a certain way or add your individual interpretation, you can claim copyright. You have to decide case by case whether your research data is an original and creative work and consequently falls under copyright. To make it even more complicated, different countries have different laws, resulting in different requirements to call research data original and creative work. To find out which license to choose for your work, you have to ask yourself several questions. Should others be allowed to distribute the work? Should others be allowed to remix your work with content from other sources? Should others be allowed to adapt your work? Should others be allowed to reuse your work for commercial purposes? These are also questions I am facing if I want to reuse your work. Can I distribute your work? Can I remix it with my own work? Can I adapt it? And if I'm working in industry or together with a commercial partner, can I reuse the work for commercial purposes? Communicating these conditions is easier using licenses. And the Creative Commons licenses do this job in an excellent way. Creative Commons, in short CC, provides a set of licenses for original and creative work, such as open access articles and in some cases research datasets. Attribution, in short CC BY, is the most permissive Creative Commons license and a mandatory element of the other CC licenses. If your work is licensed under CC BY, others can distribute, remix, adapt, and build upon your work, but they must attribute you as the original creator. If you choose the CC BY non-derivatives license, others can distribute and build upon your work, but only in its original form, with no adaptations and remixing. However, particularly remixing content taken from one source with content taken from another source is a common activity in science. For that reason, this license is usually not a good option for research outputs. However, under some circumstances, even this license can make sense. For example, maybe a poem or song should not be translated by others to avoid the risk of low quality translations and to keep the linguistic nature. If you publish your work under CC BY non-commercial, others can distribute, remix, adapt, and build upon your work, but not for commercial purposes. Intuitively, this is in line with the idea of open science, but remember that the society should benefit from published research. And it is not always easy to differentiate between commercial and non-commercial benefits. How about a researcher who needs some advertisement to finance a scientific blog? How about Wikipedia, newspapers, museums, or libraries? How about a small company that creates jobs and innovation? Strictly speaking, these initiatives could not use your work if it is licensed under CC BY non-commercial. The CC BY share-alike license allows the same activities like CC BY, but new creations must be shared under the same license as the original work. This means that others would not be able to take your work, just use or even modify it, and then publish it under a CC BY non-commercial license. It is also possible to combine licenses. You can prohibit modifications and commercial purposes, or other licenses and commercial purposes. So what does that mean in practice? Unfortunately, there is no one-size-fits-all license which we can apply to any of our research materials. We need to treat them separately. CC BY is the best option for your scientific article and also the most common one. And which license would you choose to make your research data openly available? Again, research data is a special case, and any form of restriction weakens the benefits of open data. CC BY non-derivatives is not an option because of the open data definition. Data is open if others can freely modify and share the data. So data is not open if it is released under this license. CC BY non-commercial is also not working since everyone should be able to work with the data for any purpose. CC BY share-alike means that others would not be able to take your data, modify it, and then publish it under CC BY, for example, under CC BY non-commercial. If you assign this license to your research data, it is open data, but we think carefully if such a restriction is necessary. Even the very permissive license, CC BY, makes it difficult to reuse data in big data or data mining projects that build upon large collections of data. I have another suggestion for you. When using the CC0 option, the creator of a work waives all the rights, including the right for attribution. It is important to understand that practices like citing someone else's work are an issue of academic norms, whereas copyright is a legal issue. Using research data without citing the creator is plagiarism, disregarding of the license. That is why using CC0 is the best option, because it gives others all the freedom they need and you get the chance to collect citations. By the way, research data repositories like Dryad do not even allow publishing data under a license that has more restrictions than CC0. Software should have a different license, but it can be difficult to get an overview of all the potential licenses out there. The website choosealicense.com is a great help to select the right software license. They consider several scenarios and also provide a detailed overview of the conditions and permissions of each license. Based on the licenses they mention, I created a spectrum of software licenses. It ranges from the so-called unlicensed, which is similar to the CC0 license and has no conditions or restrictions, to GNU AGPL, which has quite a few conditions. Except for the unlicensed, the licenses below the arrow are copyright licenses, whereas the licenses above the arrow are copyleft licenses. Copyleft means that any derivative work needs to apply the same license. It is similar to the Creative Commons share-alike license we saw before. So if you build on top of work that is licensed using one of the copyleft licenses, also your work needs to have this license. It sounds like copyleft licenses are more restrictive than copyright licenses, since you need to assign the same license to derivative work. However, the idea is rather to protect your work from becoming commercial, and also to protect that your users keep the rights to use, modify, and share the work. The idea is to create a reciprocal cooperation. You use open source, you provide open source. In that sense, copyleft aims to protect the continuity of open source software to the benefit of everyone. Copyright licenses are a bit different. You can change the software and distribute it under a different license as long as you credit the original authors, which is similar to the CC BY license. If you want to learn more about the concrete differences between these licenses, I strongly recommend the chooselicense.com website, which has a fantastic overview of these licenses and what they mean in detail. There are also many more open source licenses listed on the website opensource.org. So how does it look like in practice? This is a screenshot from GitLab, which is the open source alternative to GitHub. After you created a repository, you can click on Add License. And as you can see, you can select from some of the standard licenses we saw on the previous slide, such as MIT license and Apache license. And this is how it looks like after you added a license. In your repository, you now have a file called license, which contains the text of the corresponding license. This is also the file that you as a user need to check to find out whether you can build on someone else's work. The process of adding a license is very similar when using GitHub. The only difference is that you add the license during the creation of the repository and not afterwards. And this is how it looks like on Zenodo, which is a well-known research data repository. During the creation process of a new asset, you can choose the license. If you cannot find the license you're looking for, just add the license file as it was done on GitLab. To sum up, open licensing is an essential aspect of open science, since it makes clear what is permitted and what is prohibited. Creative Commons is suitable for creative works. However, we need to treat paper, data, and code or software separately. The best license for an open access article is usually CC BY. For open data, it's CC 0. And for software, it's probably Apache license or MIT license. But what if you deposit a folder that contains the paper, data, and source code? In such cases, it is recommended to have separate licenses, one for the paper, one for the data, and one for the source code. Most repositories allow to select not more than one license. Nevertheless, you can use the README file to specify each license. That's it about licenses. If you want to learn more about what we at ITC are doing in the context of open science, don't hesitate to visit our open science website.